Okay, I'm going to do a problem from 14.1 to show you how to set up and solve problems that look like this, where they're looking for absolute extrema for a particular problem. And on this one, you can see we have a polynomial function here, 3x to the third plus 12x squared plus 12x plus 2. So with that, what we want to do is first, before you do anything, what I would do is enter in on your calculator that particular function. So just go where it says y equals on your calculator, and then put in y1 spot just the original function. The reason for this is for later on we're going to use table to actually try to get the y values for where our absolute extrema will occur at. So go ahead and enter that now, the original function they give you. Okay, now we want to actually go into finding the absolute extrema, and there's a theorem that says that if there is an absolute extrema, it's actually going to occur in either your endpoints of the interval. So in this case, this interval you can see goes from -5 to 0. So it'll either occur at -5 or 0, or any absolute extrema will occur at the critical values. So what we actually need to find now is the critical values for this particular function. Now we have the original problem right here, and we just want to find the derivative for it using the derivative rules that we learned back in Unit 2. So we're going to write down our derivative right here. Our derivative will be 9x to the second plus 24x plus 12. Okay, just using the regular derivative rules. Now, when we want to find the critical values, we're just going to set this equal to 0. So we get 0 equals 9x squared plus 24x plus 12 right there. And then from there, I do see that 9, 24, and 12 all are divisible by 3. So actually, if you just divide both sides by 3, 0 divided by 3, of course, is 0, but this will be 3x squared plus, this will be divided into 3, that'll be 8x plus 4. And at this point right here, you can actually, since this is a quadratic equation, it has x squared in it, you can either factor it or you can try to use quadratic formula to solve it. So it doesn't always factor. The problems won't always factor, so quadratic formula will always get you the right answer. But I'm actually going to try to factor this one the best I can and see if it does. The numbers are nice, so maybe it will. I know I need 3x at the front of that one and then x here. It'll be same signs, both have to be positive for the 2 inside. 4 can break up a couple of different ways, so you could do 2 and 2 or 4 and 1. I'm going to try 2 and 2 first and see what that gives me, and that'll be 2x in the middle. For the outside, it'll be 6x, so 2x and 6x do make 8x. So your two critical values for this problem are going to be, when you set each factor to 0, will be x equals -2 over 3, and then x equals -2. Now you can only use numbers that are inside that interval, the ones that are in the interval -5 to 0, okay? But both of these points right here, both are inside this interval. So we're actually going to use all 4 of these. We're going to use both endpoints, okay? And then both of these x values, since both of those are in the range from -5 to 0, okay? Now this is where your calculator comes into play, since you have the formula of the original function into your calculator. So I want to go to a table mode, and of course make sure when you have your table, you have it set up to your independent variable. You ask for it, so you can actually use your own x values. And then since I have in y equals my original equation for my problem, I'm going to go to table right here above graph. So second and then graph will get you to the table mode. And I want to put in all of my values for the x's. So it's going to be your endpoints, your critical values, and your endpoints and your critical values will give you all the places where the local extrema will occur. And you can see here that the maximum, the largest which is always your y. Your y is your max and your min, just like when we did local maximum and minimums. So we see we have 2 happen twice, at 0 and -2. So there's actually a local max at 2 different places. So this is what we have for our answer. We have the only thing you have to watch for on these problems, they pretty much all boil down to this, but the only thing you might have to watch for sometimes is when you get a critical value, it might not actually be in the interval, the what I want to say, the domain that you're actually looking at, so the interval that you're actually looking at your values over. So that's the only time it might be tricky. But yeah, there's our absolute extrema right there. And of course, then we'll go and put that into MyLabs. Okay. And this is what the answer will look like in MyLabs Plus when you enter it. So you'll enter your derivative in first, sometimes, not always. Sometimes they make you find that on your own. And then, of course, you'll enter your absolute maximum and your absolute minimum whenever they prompt you for it. Okay, and remember, you can have 2 places where an absolute extrema occur. So if you put the x value in, you'll separate it with a comma.